Alright, so let's keep continue to solve the problem, which is example 5.6. There is a cord, okay, and there is a frictionless pulley. So there is no frictions. Determine the tension in the cord C and horizontal vertical component of reactions at pin A. So we have a pin here. We have a cord. There should be a tensions. But like I said, if we have a pin, the pin has two support reactions. We don't know the x-axis direction, but this one should be the AY. AY should be positive upward. This one is AX. So there are three unknown, but we will have a three equation. So it's pretty much solvable. All right, let's solve this one. I want you to draw a free body diagram. This is point A. There is external forces. Oh, no, this is not a Newton. This is a pound force. There is a cord. The angle here is 33. Tension. This is the tension. And the radius of this circle is 0.5 feet. We have two unknowns, which is AY, and let's say this is AX. The orientation is positive x-axis is directing right hand direction. Upward direction is positive y. Okay, we have a tension. Okay, let's solve the problem. Sigma x is 0. Sigma any moment at point O should be equal to, let's put it this way, A0. For the x-axis, we have this component x, AX, and what else? We have a t here, so we can decompose this force. T sine 30, t cosine 30. So AX plus t sine 30. What else, guys? That's pretty much it. That's it. Okay. For the y-axis, minus 100 pound force, which is this, and we have a AY. Okay, and what else? There's a tension, minus t cosine 30 equal to 0. Let's calculate the moment at A. This one, 100 pound force create the counterclockwise rotation. So the sign should be positive. Positive 100 times the perpendicular distance in this case is 0.5 feet. And there is a tension. So tension, we have a tension here. The perpendicular distance is still 0.5, but tension create the clockwise rotation, which is a minus sign. So t times 0.5 is equal to 0. So now we know that t is 100 pound force. Since we know this, we can plug this one into here so that we can find AY. Calculate minus 100 plus AY minus 100 cosine 30 equals 0. AY is equal to 100 plus 100 cosine 30, which is 187 pound force. This is AY. How about AX? AX is equal to minus T, which is 100 sine 30. That is minus 50 pound force. So AX is minus. AX is minus. What does it mean? That means our assumption was wrong. The AX, the direction of the AX should be left-hand directions, and the magnitude is 50 pound force. Okay, and this is the last question. Let's look at the last question. The member is pin connected. Okay, we have a pin here, pin connected at point A, and rest against the smooth surface at B. There is a smoother. This is a smooth surface. So you may understand that there is a support reaction, but there's only one support reaction. But the pin connected, we may have a two support reaction, which is AY, this is AX, and this is B. Determine horizontal and vertical reactions at point A. So let's find vertical and horizontal support reactions. Oh, by the way, we have a distributed load here. We have a distributed load here. So that means the resultant force of this distributed load is, you can just add up all the forces here, which is what? Which is the area under this line. That is the resultant force of this distributed load. Luckily, we have a dimensions here, and we know the y values, which is 80 Newton per meter. So you can calculate the area of this triangle. That is 80 Newton per meter times 1.5 meter divided by 2, right? So that is which is 60 Newton. The resultant force is 60 Newton, and where is the line of action for this 60 Newton? Since this is a triangle, like I explained, the resultant force should act here, which is one-third area, one-third part. This is 1 meter. Oh, never mind. This is 0.5 meter. This is 1 meter. So this is the line of action, 60 Newton. We have a couple moment here. Okay, let's look at the question. I want you to draw the free body diagram with me. Let's draw the free body diagram here. we have a distributed load. But we know that the resultant force should be 60 Newton, and we know the line of the action. Where is the line of the action? It's 1 meter. It's 0.5 meter. Because this is the triangle, the center of the gravity, the center of the geometry is 1/3 part here for the triangle. So this is 60 Newton. We have a couple moment, 90 Newton. Alright, let's draw the unknown forces, which is support reaction AX, AY, and we have a B. Positive X, positive Y. Alright, let's solve the problem. Well, I think you can find B easily when you calculate the moment at point A. Sigma moment at A should be equal to 0. B create the moment, which is a clockwise, no, never mind, counterclockwise rotation. So counterclockwise rotation, that means we don't know B, but we know the distance. This is the counterclockwise rotation, so positive. What else? We have a 60 Newton. 60 Newton create the clockwise rotation. So sign is minus 60 Newton times 1. And we have a couple moment here, which is a clockwise rotation. So this is 90 Newton per meter. This one should be equal to 0. So in this case, we can calculate that. B should be 20 Newton. Let's use other equation. Fx. We have 2 more equations left. Sigma fx is equal to 0. Sigma fy equals 0. For the x-axis component, there. Oh, by the way, this is not y. This should be the x. Sorry, guys. This one should be x. So we have a minus ax, and what else, guys? What else? How about the b? We can decompose this force into x-axis and y-axis, and we have an angle information here. This is 30 degrees. Yes. Yes, this one is 30 degrees. This one is 30, and this one is 60. Right? So we have a negative b cosine 60. This one should be equal to 0. I guess we made the wrong direction for the AX. This one should be the right hand directions, but let's keep it this way. Okay, so we will get the negative sign for the AX values. Let's move on to the FY. This one is negative b sine 60 minus 660 Newton plus ay equal to 0. Since we know the b is 200 Newton, we can find here, plug this 200 Newton to here, so ax minus ax is equal to 200 cosine 60. Here is the so ax is minus 100 Newton. That means our assumption was wrong. A is not left-hand direction, ax should be right-hand directions. So there is right-hand direction support reaction at point A. Okay, and what else, guys? This one. Oh, we have a 200 here. Okay, so ay is equal to 200 sine 60 plus 60. So ay is 233 Newton, which is still positive above. We made the right assumptions. Okay, so let's look at the answers. Here we have answers here, answers here. If you look at the direction of the support reaction, you can find the right directions. That's it. We learned how to apply the equilibrium equation for the solid object. We practiced some examples. Thank you for watching this short video. Have a great day.